Okay. All right. Thanks everyone for signing on today to our second of five Midwest Cover Crops Council and Iowa Learning Farms partnership webinars for this week of webinars on cover crops. Today's topic is going to be corn disease concerns following cover crops, presented by Dr. Alison Robertson with Iowa State University. I'm Ethan Teese. I'm a conservation field specialist with ISU Extension and Midwest Cover Crop Council. So I'll help moderate questions today. So if you have questions, please just enter them into the chat and we'll answer them at the end of the webinar. Take it away, Alison.
Thank you, Ethan. I'd like to thank the Midwest Cover Crops Council for inviting me to speak today. And I'm going to be sharing with you some research that I've been doing for the past 10 to 12 years on cover crops. Most of my research, if I can advance my slides, there we go. Most of my research is focused on winter cereal rye. And the reason for that is because it is by far the most popular cover crop that's grown, and for numerous reasons, right? Because it protects the soil, reduces erosion, we have greater infiltration, we have improved nutrient cycling, and because it has great benefits in terms of soil structure, enriching organic matter, etc. And so most of my work is with winter cereal rye. The problem with winter cereal rye is when you plant it before corn, occasionally in some years, you can have a yield reduction or a yield drag, if you prefer. And farmers have been concerned about that for a number of decades. And a lot of times, the reasons for that corn yield have been pointed at uneven planting depth, low soil temperatures, allelopathy, nitrogen immobilization. And with all of these factors, what can happen is you can get an uneven stand of corn after you plant into cereal rye. And the problem with an uneven stand in corn is that we then, those plants that are behind their neighbors, a growth stage or two behind their neighbors, often become weeds and produce these very small or no ears. And so that's probably where this yield drag is coming from. So 10 to 12 years ago, Tom Casper, who's now retired, but a USDA ARS scientist, came to me and said, do you think seedling disease could be a problem? And when I thought about it, seedling disease can reduce stand, but more importantly, seedling disease often results in uneven emergence. And with that uneven emergence, that leads to these weedy plants that occur in the field. So I was thinking about this at the weekend and just thinking that seedling diseases, it's a very subtle disease. It's for those of you who grow soybeans, I suspect many of you do, you'll know soybean cyst nematode, right? A lot of times we don't see the yield loss that soybean cyst nematode is causing on those soybeans. And it's a little bit like that with seedling disease. So it's kind of hard to see that there's a problem there unless you really look for it. So one of the first things that we did was, first of all, we had to find out whether winter rye could be a host for these seedling pathogens. And so we took winter rye, did some isolations from the roots, and we recovered pathogens belonging to Fusarium and Pythium. And when we took those pathogens and put them onto corn, we got this root rot on the corn. And so you can see those white arrows there are showing the rotten radicals. And you'll remember with a corn seedling that up until V5, V6, that seedling root system is very, very important for the growth of that corn. And so if it gets affected in any way, that's going to reduce the vigor of those seedlings, right? And so if we have radical rot or mesocotyl rot or rot on those seminal roots, that plant is not able to uptake water and nutrients efficiently, and therefore it's not able to grow as vigorously as it could, and it then gets kind of held back and becomes this kind of weedy corn plant. So having shown that winter rye was a host of corn seedling pathogens, we then wondered whether it could be a green bridge for these seedling pathogens. So what do I mean by that? I mean that we have the winter cereal rye that's growing over the winter. In the spring, it starts growing again. We have pathogens that are infecting those roots, not necessarily causing disease on the cereal rye, but they are kind of hanging there in the roots. And then when we plant corn too close to that cereal rye, what happens is we're kind of planting corn into this petri dish of pathogens, so that rye is providing this bridge effect. If we look at that in terms of kind of populations, right, what will happen is we always have this background population. We always have Pythium and Fusarium in every field. They're endemic to every field. Okay, but with the winter cereal rye, what happens is that kind of increases the population. And when we terminate the winter cereal rye, we get this increase in population, which if there's no host, it'll just die back down to those background levels. So we wanted to see whether first of all, was seedling disease a problem on corn following cereal rye? And could we reduce the seedling disease by planting when the inoculum was low? So what happened if we terminated the winter rye, waited a few days until that population declined, and then planted the corn? And so this is the first field experiment that we did. This was a corn-soybean rotation, being in cover crop corn-soybean rotation for a couple of decades. So it was a field that Tom was really familiar with. And this is our data from 2015 for our seedling disease. But you can see the treatments there. We had our no rye check, and then we had the rye that was sprayed with glyphosate, so terminated 25 days before planting, 17, 8, and 3 days before planting, and then 2 days after planting. And when we look at the data, first of all, that you can see that when we plant corn following cereal rye, we have greater radical rot incidence in all of our treatments. But most importantly, if we plant corn within 8 days of terminating that rye, almost every plant, so 80% of the plants, showed radical rot incidence. What does this mean in terms of yield? So this experiment was done in 2014 and 2015, and these are the yields that you can see here. So what you'll notice is that in 2014, the only treatment where we had a yield drag was when that rye was terminated 1 to 2 days after planting. Whereas in 2015, when we had very high biomass, we had this yield drag across all of our rye treatments, but it was particularly bad when we terminated that rye within 8 to 10 days of planting that corn. And so I want to pause here for a second and just reiterate the facts that this yield drag that we see with corn following a cereal rye cover crop does not occur every year. It does not occur in every field. So, but we have consistently shown that it can occur over a decade of research. So this came up with our recommendation that if you were going to plant corn following a winter rye cover crop, that you should wait at least 10 days after terminating that rye cover crop. And by terminating that rye cover crop, I mean spraying that glyphosate. So spray the glyphosate, wait at least 10 days, and then plant your corn. But of course, with the cold, wet springs that we have, oftentimes we can't get into the field to terminate the rye ahead of when we want to plant the corn, and also the glyphosate is not effective. And so I know that there are a lot of farmers out there who are thinking about planting green. And so based on our initial experiment we did, Tom and I were really concerned that planting green was not the way to go. So we did an experiment to see whether planting green could increase seedling disease and contribute to yield drag. And we did this in Iowa, and we were able to show that, yes, that did occur. But what's been really neat is that the last 5 years, we've been working with the Precision Sustainable Agricultural Group. And there we were able to test the effect of planting green in 16 states across the US. And so this was part of a big USDA-funded project, and we were responsible for what was called Common Experiment 2, where we looked at the effect of winter cereal rye termination timing on slugs, pests, diseases, weeds, and corn performance. I'm only going to talk about the diseases here. But this slide here kind of gives you an idea where these trials were carried out. The trial was completely standardized. So we tried to keep factors as similar as possible across all of those locations. But so what we did was we terminated the winter cereal rye at different times before the corn was planted. So we had our planting brown treatment, which is where the rye was terminated at least 14 days before that corn was planted. And that's what we recommend, right, to reduce that green bridge effect. And then our other treatment was the planting green treatment, where we terminated the rye 0 to 7 days after planting the corn. And then many of the states included a planting brown-green treatment, which was where the rye was terminated 3 to 7 days before planting. And that treatment was included because we knew we would get, well, we knew we should get seedling disease in that treatment, right? And then, of course, we have our no rye control, which is just bare soil. Okay, so if we look at the winter cereal rye biomass across locations, you can see all the data in that very busy chart there. But really what I want to point out was that when we compare the biomass of the cereal rye in the planting green versus the planting brown treatment, you can see, no surprise really, it's kind of a duh, that at most of the locations, 14 of 16, 13 of 15, 13 of 14, in those 3 years we did this trial, that the biomass was much greater in the planting green than the planting brown. Let's go on and look at seedling disease. So this chart shows the locations with the root rot severity across those locations. And you can see that in the no rye control, we had seedling disease that ranged from 1 to 22% severity. And then with the different treatments, we had the disease severity ranging from 1 up to almost 40% in that planting green treatment. But really, in summary, what we found was that seedling disease was more severe in the planting green treatment than the planting brown in 12 of the 15 locations in 2021, all locations in 2022, and 9 of the 14 locations in 2023. So it was exactly as we hypothesized, that when we plant green, we're going to see more severe corn seedling disease. And that did hold out for the majority of our locations. We are now going to take this analysis further, and because we have so much metadata collected from each of those locations, we're hoping to go in and do some sort of random forest analysis, which will enable us to look at what factors are likely increasing that risk of seedling disease. And by knowing that, hopefully we can come up with best management practices from that, or at least an idea of what's contributing to the seedling disease. But of course, so we've got an increase in seedling disease, but what about yield? So this is our relative corn yield. And what we did was we compared the yield of planting green versus planting brown across all the locations. And so you can see that the yields of planting green were anywhere from 30 to 73% less than the planting brown, although in some cases we did get yields that were greater in the planting green than the planting brown. If we summarize that, the relative yield of planting green was less than that of planting brown at 10 of the 13 locations in 2021, 11 of the 14 locations in 2022, and 10 of the 12 locations in 2023. So basically, the results of that study just re-emphasize what we'd known from our initial research, that planting into a green winter cereal rye cover crop can negatively affect corn because of this increased seedling disease, and that increased seedling disease can result in this yield drag. So I've been talking about seedling disease management, and I've really been focused on planting when the inoculum is low, right? So delaying the corn planting until after you've terminated that rye. But another way that we can manage seedling disease is to plant where the inoculum is low. And what do I mean by that? I mean basically social distancing the corn from the cereal rye. And so I had a grad student a few years ago who worked with me, where we looked at these social distancing experiments. These were our treatments. We had no rye as our control, and then drilled rye. So the corn would have been planted right into that rye, right? So we would expect a lot of disease there. And then what we did was we had corn that was 7.5 inches from the rye. So to do that, we plugged one of the drills over the corn row. And then we also we had a fourth treatment where we plugged 3 of the drills and then planted that cereal rye in the middle of that corn. So we planted the cereal rye on 30-inch rows and the corn on 30-inch rows. So the corn was now 15 inches away from the rye. And this is the data that we got. So from the biomass, sorry, I have the crud, and so I keep needing to take a sip of water just so that I don't cough. Okay. So 2019, 2020, you can look at that biomass. You can see that the biomass we get in the drilled with the one plugged drill is pretty similar to the biomass that we get when we have those 4 rows, drilled rows. But in the 15-inch, we have quite a fair amount less biomass, right? Especially in 2019. So we're looking at half the biomass in 2019 with that corn separated 15 inches from the rye, and maybe about 75% of the biomass in 2020. If we look at seedling disease, so what you'll notice is that in 2019, we had much lower seedling disease than we did in 2020. And really, in 2019, there's not a lot of difference between the treatments and seedling disease. However, in 2020, you can see that where we separated the cereal rye, 15 inches on either side of the corn, we had a lot less disease from where that cereal rye was planted into the drilled rye, or where we just had that one skip row, if you like. So this was exciting because it kind of showed that by socially distancing the corn from the rye, that we could reduce seedling disease. What about in terms of yield? So in 2019, we got pretty good yields, and the yield where we separated the corn from the rye, where we were only planting on those 30-inch rows, the rye on the 30-inch rows, the yield was pretty similar to where we had no rye at all. In 2020, didn't get as good as yields, about 200 bushels, and where we separated the corn 15 inches from that rye, we had about a 10% yield drop compared to a 50% yield drop where we were planting into that drilled rye. So basically, from this research, we were able to show that social distancing the corn from the winter cereal rye was advantageous in that it reduced seedling disease, and by reducing seedling disease, we could mitigate that yield drag. But we had some concerns with this because really we're planting cover crops for the agro agroecosystem services that they provide, right? And seedling disease is only a problem in some fields in some years. And so if we think about this, if we're going to social distance this winter cereal rye, when we think about how much cover is on the landscape, when we're plugging one of those drills, we have 25% less cover on the landscape. When we're plugging 3 of those drills, now we have 75% less cover on the landscape. And so that was a big concern because we were concerned about how that might affect soil health, how that might affect infiltration, soil erosion, and how that might affect nutrient cycling. And so what we did was we paired up with a USDA ARS scientist, Peter O'Brien, and we wondered what would happen. Could we combine planting green and social distancing? So by planting green, we would get more biomass, right? Which is what we want. We want lots of biomass. I'm sorry. So if we have the planting green, we can get the biomass we want. And if we can social distance, then we can reduce those negative effects that we've shown with planting green. So in this study, what we did was we had our positive control, right? Whereas where we planted the corn into the drilled cereal rye, and this was planted green. So we know that this is not what we advise, right? And then we had, for our other treatments, we had a skip row. So this is where we plugged one of the drills over the corn row, and now we have 3 rows of rye in the middle of the corn, okay? And then we terminated that rye 10 plus days before planting, which is what we would recommend. But then we also left it and planted into it green, and then terminated that rye at planting or up to 3 days later. So we had the skip row, and then we also had the 30-inch rows again, once again, planting brown, to use that terminology, and planting green. And finally, we had our no check of winter cereal rye. So this experiment was really interesting. You can see the 2 years. We've just finished this experiment, and we're just writing it up now to publish it. But you can see the comparison in the biomass between 2023 and 2024. Last year was just so wet that we could not get into the field to terminate the biomass. And you can see that in the planting green plots, our rye had started to head out in those. And this really had a big impact on our results. So this is the biomass data in kilograms per hectare. But what you can see here is a lot more biomass in 2024, right, compared to 2023. And probably the most interesting thing in this, in the 2024 data, is that even in those 30-inch rows, we managed to produce a lot of biomass. And so one of the things that we noticed was because that there was so much space in those 30-inch rows of rye, that the rye just bushed out and just took advantage of all that extra space, had a lot of branching and a lot more roots, etc. When we look at the corn seedling disease, so we had similar seedling disease in both years. Here's the no cover crop data. So once again, you can see that in that drilled treatment, we're getting a lot more seedling disease with that rye cover crop compared to where we have no cover crop. But you can see that when we socially distance that rye from that, socially distance the rye from the corn, that it really helped to decrease the amount of disease that we saw. And so in those 30-inch rows, And even with the skip row, we saw, half as much disease as we did in the drilled rye, and in the 30-inch rows, even less than that. And then we didn't see a big difference in disease between planting green and planting brown in this study. If we look at the yields, so in 2023, the yields were very similar across all treatments, and we really didn't see an effect of treatment there. But then, and very similar to the control. But then in 2024, this is where we saw a big difference. Sorry, I'm forgetting my animations here. So 2023, you can see our yields are all very similar there. Whereas in 2024, first of all, we have lower yields, right? 183 compared to 234. And then with planting green into the drilled or the skip row, we had about a 50% yield drag compared to the 30-inch rows where we had maybe a 75% yield drag in those there. So that socially distancing that rye still helped mitigate that yield drag a little bit. Okay, so Peter also collected data on infiltration, and this is the infiltration data compared to the no cover crop. And so what you can see is that with that cereal rye, that we were getting better infiltration in both years, and there weren't really any treatment effects. This data was not statistically different. There was a lot of variation in the data, but even in those 30-inch rye rows, we were still getting better infiltration than where we didn't have cereal rye. And then we also collected data on erosion. And so you can see that erosion data there, 85 grams per hour in 2023 compared to 28 in 2024. But you can see that we are getting reduced erosion with those treatments. But once again, a lot of variation in the data, so difficult to show any statistical difference between the two, and no real treatment effects on that erosion data. So basically, and just summarizing this work, was that we were able to show that planting green into a winter cereal rye cover crop that was socially distanced from corn, that we had reduced seedling disease, we mitigated yield drag. And in this experiment, we didn't see an effect on infiltration or on erosion of those treatments. So just to sum up what we've been talking about, I've talked a lot about seedling disease, and I always feel like, I don't know what it would be like I can't remember what the character's called, but just like a downer when I come in and I start talking about seedling disease with cover crops. And I want to reiterate that this is not something that happens every year. It doesn't happen in every field, but it can happen, and it can lead to yield drag, right? But the most important thing for me is that the benefits of planting those cover crops in terms of protecting our soils, nutrient recycling, and just general soil health, those benefits far outweigh the negatives associated with the cover crop, which would be, in this case, seedling disease. In actual fact, I'm not sure that there are a lot more negatives than just seedling disease, right? So and then to summarize what we've been talking about, that basically our recommendations are to mitigate yield drag when planting corn after a cereal cover crop. It's best to wait at least 10 days after termination to plant that corn. That lowers those pathogen numbers back down to background levels, you're not gonna, so you're at less risk for seedling disease, right? And if you do choose to plant green, then you should try to socially distance that corn from the cereal rye. And so that might mean some kind of precision planning, right? Precision planting. So blocking a drill or something. Another thing that we'd really like to explore is strip till. I think that strip till could certainly help just move that cereal rye residue roots and those pathogen populations away from the corn, and that could benefit that corn in that way. So I I have a lot of people to acknowledge. A lot of staff and students have been involved in this work, so we want to acknowledge that. Um, I've collaborated with a lot of different people. I mentioned Peter O'Brien there, and then I also I'm really sorry. I also mentioned the Precision Sustainable Ag Group, um, particularly those who were involved in Common Experiment 2, and I shared some of those data. I've also been working with Marshall McDaniel and Mark Licht and Silvina Arias on some new research that where we're looking into nitrogen immobilization and allelopathy and the role that they may play in seedling disease. A big thank you to Tom Casper, who dragged me into cover crop research. It's been a blast. And of course, I need to thank those folks who have funded my research, the Iowa Nutrient Research Center, USDA NEFA, and then also the Sustainable Agricultural Research and Education Program, who funded Sarah Kurtz, who did the work on the initial work on the social distancing. So thank you all for being here today, and I'm very happy to take any questions. Ethan, I am going to switch onto your slides now.
Okay. Yeah, so we'll do questions here after a few housekeeping things. For those of you wanting Certified Crop Advisor CEUs, please email Madeline at Michigan State. Her email's there on the screen, and I think she'll put it there in the chat for you to copy and paste as well. Please send us your name, the name you entered to watch the webinar if it was different from the name in your email, and then your CCA number and that you watched today's webinar. So include the date in there. We need those by February 18th for you to get the credits. Go to the next slide, Allison. Iowa Learning Farms also has a voluntary demographic survey. You only need to do this once for 2025. So if this is the first webinar you've watched from Iowa Learning Farms and you haven't completed this survey, please scan that code or go to the link there and take that demographic survey for them. Okay, next slide.
Oh, did you get it? Yes.
I think we missed one. Can you go back one?
Really?
Yep.
Okay, there we go. Sorry.
Tomorrow's webinar will be Dr. Aaron Day from the University of Nebraska-Lincoln talking about soil compaction and cover crops. So be sure to tune in for that at the same link and time tomorrow. And then, yep, you can go to the next slide. And if you want to see all of Iowa Learning Farms' previous recordings, they're on the website there, on their YouTube link and website. And then Midwest Cover Crop Council's videos are on their YouTube page. And today's webinar and yesterday's and all of this week's recordings will be posted there at the conclusion of these webinars. Are you ready for questions, Allison?
Yes, I am. I think you have one more slide.
Oh, do I have one
Save
more?
the date.
I do.
Yes.
Be sure to save the date for Midwest Cover Crop Council's 20th anniversary annual meeting and conference that will be held in Dubuque, Iowa in 2026 from February 10th and 11th. So be sure to mark your calendars on that and watch for emails on that to get registered. Okay, I think we're ready for questions now.
Yes.
All right, the first one I have here is, are you going to see a big difference in the weed suppression from the rye when terminating 2 weeks before planting compared to planting green?
That's a great question. So, um, no, it depends on how well that rye grows during that spring, right? And how much biomass you get. So we know that the more biomass you get, the better your weed control is going to be. So yes, if you're terminating 10 plus days before you plant your corn, you may not have enough biomass there to control the weeds.
Okay, our next one, I think all of these came in when you were talking about your social distancing trials. Was there any soil data like soil moisture, soil temperature, bulk density collected in that study?
Good question. Definitely not bulk density. I think that we did have probes out 1 year for soil temperature and moisture, but I'm not sure that we really looked at that data very closely. So I should just say no.
Okay. Besides the infiltration test that you talked about before,
I
uh,
beg your pardon, Ethan, sorry.
you did talk of the infiltration in some of those soil tests you did talk about. So I think
Yes,
you covered
yes.
some of
So,
it. That was after that question had came in.
okay.
Uh, Next question, is there any seed treatment options available for corn to prevent the occurrence of seedling disease?
That's a great question. So all of our research has been done with commercial corn, commercial seed treatments. Um, And we did do some research where we looked at different components of those seed treatments. Um, Obviously, well, we're mostly dealing with Pythium. And so it's those seed treatments that are going to work against Pythium that are going to uh, work better in these seed treatments. However, remember that those seed treatments are only effective for about 14 days. And so, yeah, um, the seed treatments are not going to completely protect you. Last year, we did some work where we tested some biologicals. Unfortunately, none of those really helped reduce the seedling disease. But we're hoping to test again this year and maybe include some new biologicals. So we are looking at seed treatments. We just haven't found any that really work yet.
Is seedling disease concern only in the case of winter cereal rye as a cover crop, or would it be a problem planting green into all cover crops?
Another good question. So the Pythium and the Fusarium that we're talking about have a very wide host range, and so they're probably going to be on other cover crops. Having said that, we did do some work with camelina ahead of corn, and we had reduced disease with the camelina ahead of the corn. So so I think if you're planting a grass um, cover crop before your corn, you're still going to get those issues, right? Whether you have wheat or triticale or cereal rye, you're still going to have those. But if you're planting like a broadleaf species, hairy veg, or camelina, you're probably going to have reduced disease in those cases.
All right. The next question here is, can you speak to some of the conditions like soil type or environmental factors that are conducive to seedling disease?
Okay, so the seedling disease that I'm talking about is caused by Pythium, and Pythium is a water mold. So, any conditions where the soils are very wet are going to favor Pythium there because the Pythium is going to produce these little spores that swim in the water, and then those spores are attracted to exudates that are released by the germinating corn seed. So, having said that, other conditions that are going to favor seedling disease are going to be those cool conditions. So, if we have in one of those years where we didn't get a lot of seedling disease, I want to say it was 2019, we had a very warm, growing period, and our corn emerged within 3 to 5 days of planting. Under those conditions, we're not going to have a problem with seedling disease. The corn basically outgrows the infection. But when you have conditions where the soils are cool and the corn's sitting in those cool, wet soils for 10, 14, 21 days before it emerges, those are the conditions that are going to increase your risk of seedling disease. And then I also mentioned that we're going to be doing that metadata analysis, right? And so I'm hoping that from that metadata analysis, that these kind of things will show up, right? Yeah, but if you think about it, when that corn seed's just hanging out in the soil, germinating, leaking all these exudates, and it's cold and it's taking a long time to emerge, there's just more time for the pathogens just to attack and start causing root disease.
Great. Our last question here I have in the chat, unless some more come in. What are some options for organic growers looking to use cereal rye as a cover crop and minimize disease?
I would say, so for organic growers, you're going to be wanting a lot more biomass, right? To help you with your weed control. So I would think if you could precision plant that rye just so that you could socially distance that from the corn, that would help. The other thing is just to plant your corn a little bit later into warmer soils so that you can get that very quick emergence. If you can get that corn emerging, within a week of planting, then I would say that your risk for seedling disease is a lot lower. So those would be my best recommendations for organic growers.
All right. And that looks like all the questions I've had come in the chat so far. So thank you, Alison, for presenting today. And thanks everybody for tuning in. And be sure to check out the rest of this week's webinars.
Thank you for having me, and thanks everyone for taking time out of your day.